we're going to come in, we're going to add antabuse. And antabuse is going to sit right here and block the activity of enzyme number 2. So you drink alcohol, what happens? Ethanol comes into your body, it reacts with enzyme 1, and what occurs? It converts it into the acetaldehyde. So you got some acetaldehyde, and then what happens? That's it, right? So what is going to occur when you drink ethanol in the presence of antabuse is your amount of acetic acid and that breakdown pathway is going to go way, way, way down. And the concentration of acetaldehyde in your body is going to go way, way, way up. And where have you heard the word aldehyde before?
Formaldehyde.
Formaldehyde, which is you're not supposed to drink until you're dead, because that's actually what we use to preserve dead bodies. All right? So aldehydes are not so good for you. And when you take antabuse and you block the second enzyme, you boost the amount of acetaldehyde and it makes you violently ill. So if you fall off the wagon as an alcoholic who's taking antabuse, you get super, super sick. And that helps reinforce the negative associations with ethanol. And so you learn to not drink alcohol because of that. At least that's the desired effect. Yeah? What's that? Oh, would it go back this way? Is that what you're asking? So if you're under 21, you can't buy alcohol, but you can buy vinegar. How much vinegar would you have? Well, so enzymes can, they can drive reactions in either direction, but they tend to drive them. So when there's an abundance of one, the enzyme will push the reaction in the other direction. And if there's abundance of the product, it'll push the reaction in the other way. That said, I would imagine there'd be a really, really massive dose of acetic acid you'd have to take to get anything leaking back to ethanol. But so my suspicion is probably not. You can't get drunk from drinking acetaldehyde. I don't know if you guys have any thoughts about that. Yeah. Just don't drink it. That's the conclusion. All right. So that's an example of, in a biological system, how if you want to make a product, you often have to do a series of reactions to the substrates to get there. It's not a one-shot deal. And so what we're going to do today in lab is we're going to look at how the temperature around an enzyme affects its activity. And we're also going to look at how the pH around an enzyme affects its activity. So we're going to be looking specifically at sort of the optimal conditions that enzymes operate under. And I want you to think about why certain enzymes would have optimal activities at certain temperatures and why certain enzymes would have optimal activities at certain pHs. All right? So that's going to be one of the sort of take-home lessons from the lab today. So why don't we take a break, and then we'll get started with the lab.